Hello everyone, welcome back. So in this video, we are going to understand a very important question because this question is based on previous video that we have done yesterday. Okay, the question is saying that find the number of ways to place people two and people one we have already done. Okay, so question number 3027. It's a very interesting problem, and we will break down this problem in very simple steps, we can say. And today we are going to tackle this problem. And so if you are still not understanding, so don't worry. By the end of this video, you will fully understand the problem and the logic and how to implement the solution. So I'll use the Java. You can use the similar code, that is plus or in the Python, okay, or JS. So here's the problem. Let's understand. Very first, what we have given a set of points on the 2D plane. Okay, that is why it is saying you are given a 2D array that is called points of size n cross 2. Means each pair contains two elements, right? It represents the integer coordinates of some points on the 2D plane where up points contains two pair x and y pair, right? Means a point contains two pair on the 2D plane, that is called pairs, and it is x and y, right? Now understand what we have given. It is saying we define the right direction of a positive x axis increasing x coordinate and the left direction of negative x axis, that we know, right? Means if we go in the right side, it is a positive x axis, and if you go to the left side, it is a negative x axis. That is thing that we know from our childhood. So it is a increasing coordinate, we can say, and this is, we can say, decreasing x coordinate. Means x coordinate contains in the direction. Let me tell you how. So if you observe this, right, this is called positive side, and if you come from here to origin to this side, it is a negative side, right, of a x coordinate. That is heading. Similarly, we define the uh, up direction, that is a positive y, and you can say increasing y coordinates, and down is negative coordinates. So let's suppose, don't have here, okay, so let's suppose in this case this is a upside, it is a positive y. When will come downside is a negative y side, right? So this is what we have given here, this is statement. So till there nothing is there, that is simple. A 2D array we have given, points we have given like that, and the statement that we know in the Cartesian plane. Okay, let's read further. So you have to place n people. How many people you have to place? N people, including Alice and Bob. Okay, Alice and Bob we have to also include at these points such that there is exactly one person at every point. It is saying, so these are the points that we talk about, right? Point array. So each point contains at least one person exactly there, right, at every point. Alice wants to be alone with Bob, right? So Alice will build a regular fence with Alice positive Alice positions, right? It is saying that Alice wants to be alone, right? Okay, and so Alice will build a rectangle fence. You know the rectangle fence. Okay, so two sides will be same and two other sides will be different. Okay, with the fence. Okay, so the Alice position as the uh, upper left corner. Okay, and Bob position is the lower right corner. Okay. Mm-hmm. Okay, so it is saying it is upper left corner, and Bob's is saying Bob position will be as the lower right corner. Understand? So okay, so let's suppose there is a rectangle, right? And the rectangle, if you take the upper left, right, means the from the left side there will be upper left, right? That position will be Alice position, and the down one will be down corner will be Bob position of the fence. Now it is saying note that uh, fence might not enclose any area. Okay, and it can be aligned. Okay, if any person other than Alice and Bob is either inside the fence or on the fence, Alice will be sad. Okay, return the number of pairs point where you can place Alice and Bob such that Alice does not become sad on building the fence. Okay, means we don't need to do that simply. So this is what we have given in the note. In the note, it is saying that uh, Alice only built a fence with Alice position as the upper left corner and Bob position the lower corner. For example, Alice cannot build either the fence in the picture below with four corners 1 1 1 3 3 1 and 3 3 because Alice is at 3 3 and Bob is at 1 1. So Alice's position is not upper left corner and Bob position is not lower right corner of the fence. With Alice 1 1 1 3 and Bob 1 1 position, Bob position is not the lower corner of the fence. Okay, this is what we have given. Okay, you can see it is saying that wait, yeah, Alice cannot build the fence in the below picture with the four corners is what we have 1 1, as you can see here we have is 1 1, then we if we'll take about here it become 1 3, then if you go to up one it become 3 1, right, and this is we have 3 3. So here in this picture we can say Alice cannot build the fence because it is saying Alice is at, let's suppose, 3 3. Okay, and Bob is at where 1 1. Okay, so Alice's position is not the upper left corner, it should be here, right? 1 3, but he is at 3 3. Alice is at 3 3 and Bob is at where 1 1. So this position is not different, it is opposite. So Alice and the Alice position is not on the left corner here, right, upper left corner, and Bob should be here, so he's not there, lower right corner of the fence. And if we talk about this one, so here Alice is at 1 3 and Bob is at here. Alice is at the right position, but the Bob is at wrong position, he should be here. So Bob position is not on the lower side, right? So try to understand. Okay, very first, it's very simple, it is saying, okay, position should be there. Alice should be in this corner and Bob should be in this corner, and whatever we have given in the here, right, it doesn't matters the points, we just need to find the those points, right? We have to return the pair of the points, number of pair points where Alice and Bob can place. Okay, and this would not be sad, this would be happy. Okay, okay guys, let's understand this example. Okay, very first points we have given is 1 1 2 2 and 3 3. Okay, so there is no way to place Alice because there is only 3 points we have given, and so obviously there will be no what you call rectangle. Okay, so we can say there is no place to place Alice and Bob, and so the fences cannot be built like that, we can say that. Okay, come to, okay, no, it is saying Alice and Bob upper bound and lower bound. Okay, okay. So it is saying there is no way to place Alice and Bob such that Alice can be built a fence with the Alice position, as I told you. Okay, leave it. Let's understand here. As we can see, these two position was required, right, for Alice and Bob. Let's try to understand. So there are two positions required, one for Alice, another for Bob. So we'll place the Alice at 4 4 and Bob at 6 2. Okay, So these two corners, they are sitting and they are not sad, right? So if we'll talk about 2 6, right, there is another position where allies can sit, right? And if we'll build the another here, right, we can say okay, Bob can sit here. Okay, so we can say if we'll take here the allies, we can sit here and we can make a larger one, right, like this, a rectangle, and this will work. Means from here to here we'll start and we can make the rectangle, right? Can we see that? We can make it, and so this will work, okay, like this. So we can make the rectangle here, and then we can make. Another is that we can uh, use this point, so we can use this point and this point, right? So if we say, let's suppose you cannot, allies cannot be at 2 6, let's suppose if you cannot place here and Bob at here, right? So because the person at 4 4, right, will be inside, this is not correct. So the possibility is that any person should not be inside of the rectangle in the fence. There should be two person is there. One is allies and another is Bob. Otherwise they will be unhappy. Okay. And so we'll not consider this case. We can consider only these two cases. I hope you understand the problem. Let's understand the code. So try to understand that how do we efficiently solve this problem. The ways multiple that we can discuss, but try to understand how to implement it. Okay. Very first, so we should coordinate compression, right? And we will use the coordinate compression, and we'll use 2D prefix sum. Okay, so I'll talk about later about these points, but before that let's understand how to implement it. Okay, so you know the coordinate compression, so there will be large x and y coordinates, right? And we have to move into the smaller one if you talk about the compression, right? So the consecutive indices can be reduced, so we can store the points into 2D matrix and we can do that, right? But there is concept of 2D prefix sum where we'll uh, quickly count the points inside the any rectangle in a constant time. Okay, so those things we will do. So very first try to understand how to do that. So as I told you, very first we'll do the coordinate compression, and for the coordinate compression we'll compress the points. Okay, how we will do that, that we will discuss later. Okay, but very first understand what are the approaches there, right? Very first we'll do the coordinate compression, then we'll use how we will do that, that is different thing. Then we will build a, you can say, matrix, right? And then we'll use 2D prefix sum. Okay, so 2D prefix sum will quickly count the point inside any rectangle in a constant time, and then once we will have, there will be a fair points will be there, pair points will be there, that that we will do what, uh, we'll check all the pairs that allies and Bob use the prefix sum to see if a rectangle is empty except for the allies and Bob. Okay, so that is we are going to do, and once that is done we'll find the pairs and we'll return the pairs. Okay, so let's talk about the things. So this is what we have given in the points, right? So what we will do, uh, very first we'll compress the coordinates, right, as we talk. So to compress the coordinates, right, uh, means we have to reduce the large number of dense range, so we can create a matrix. For example, we have some values, let's suppose x values we have 10, 50 and 100. So it can become how, let me write here, we will, or we can say here. Okay, let's suppose how to do that. Let's suppose you have some x values you have, okay? And this is, let's suppose we have 10, let's call 50 we can take, and 100 we can take, right? So this is we have x values. Okay, so if we'll do the uh, compress coordinates, right, it means it will becomes what, it becomes, we can take 1 2 and this is 3, right? Let me see that. Same for y. As we have done for x, we can do for the same for y, right? Can we say that? So the thing is, we will reduce the large number to the large numbers to the dense range, so we can create a matrix, right? Like that, we'll do that. Okay. So for that, some of the things we need, like x map we need, y map we need, as we have discussed here. Okay. Then we'll create points to compress. Okay. So how we'll do that? Very first, you'll collect all the points and you will add on to those respective maps in x map and y map. Then to compress the coordinates, you will take a sorted you can say set, we can say is the type of you can get from the map, and you will create a list that will contain the key set of the map, right? So you need to do the sorting by the collection framework, and over the iteration we'll go for all the iterative sorted value, and um, we'll put the in the map, right? So sorted at I, and you will add I plus 1. Okay, like that you will do, and you will have the x map, okay, updated. Now you will do the compress y, and similarly you will do the same thing that you have done for the x coordinate. So x coordinate and y coordinate you need to compress. Then you have to compress the columns, right? So size plus 1 you will do, and you have to compress it. Okay, now you have to build the grid, right? So once you will build the grid, then you have to find the prefix sum. So very first, you build the matrix of points, right? So next we will create the 2D grid, right? And that is we can say for grid at I and j is equal to 1 if the point exists, otherwise it is 0. Okay, so that we have to take care. So let's suppose we'll take those points, you will get the those points you will create the point. This is a class that we'll discuss later, but very first you understand how to create a points. Create a points, we need two things: axis, x and y value we need, and then we will create the point. Then you will put on the compute, the each point will compute, because this is a pair. And so grid at the respective value, let's suppose grid at I and j, we can say for this is x and y we have, so it is 1 if a point exists, we can say. So this point exists, right? And so we are marking that this is existing, and so we are adding equal to 1, otherwise we will set the value 0. Okay, so that we don't need to do. Then we will build the 2D prefix sum, we can say array. So prefix sum at I and j is, we can say, it's a has a point from 1 to ij, we can say. And this will we will calculate by how, if we know the x2 and you can say if you have 2 points x1 and x2, y and y2, like that we can say if 2 points we have, right? So we can count any rectangle using this formula. Okay, so the formula is what? We have to find the sum is what? Prefix at x2 y1 minus prefix at x1 minus y1, x1 minus 1 or y1, and minus prefix at x2 y2 minus 1, like that we have, and we can say. Okay, so we have this prefix, we can say we'll do the sum, like that we will calculate. Okay, I know you understand how to how we are going to count it. So this, let's just count any rectangle in O of 1 time using this formula, we can say. This is what our sum is coming. Okay, then in the next point, we need to sort these points, right? So sort this point for the left to right ordering, and for that we have to sort it. Then we need to count all the valid pairs using the prefix sum. Okay, so this is our final step where we need to iterate over all the pair of points, and for that you have to go for all the points. You have to check using the prefix, right? You have to count all the pairs using the prefix, right? So we know we will only consider the top left and bottom right candidates, and for that we can say this thing, right? We can get these 2 points, right? We'll compress these points, we'll get the compressed points, we'll check the x and y coordinates for both. Now uh very first what we need to do, we have to check if the current pair is at top left to the bottom right, and we'll use the prefix sum to see if the rectangle contains only Alice and Bob. If yes, we will increment the answer, right? So for that we'll check the value, and we'll increment our answer that yeah, we found that we found that the rectangle only contains Alice and Bob, and so yes, we are incrementing our answer, that is valid pairs, right? And in the last we'll return the valid pair. Okay, so that's what we need to do. Okay, and this will take O of n square, because we are taking uh, fast this is fast enough for the reasonable input size, and this is we are doing only because of the two loop is moving over all the points. So if you will tell me to how to implement it, so I'll simply say, I'll summarize this. Like suppose I will very first will compress the coordinate to fit the grid, and then we will build the 2D prefix sum for the fast rectangle queries, so we can find the valid pairs. So we'll iterate over all the pairs of the points, and we'll count the valid one, and we'll check the Alice and Bob placement is there, and then we'll increase it. So this is how we'll ensure we don't need to check each rectangle naively, and we'll save a lot of time by making it a scalable code. Okay, so that's what I have, and thanks for watching, and happy coding, guys. If you still need anything, okay, one thing is left. Okay, so this is the points. We have created a utility class or helper class, we can say, where the points contains two things, x and y. So this is our constructor. You know how to override the equals method and hash code. So to override the equals method, right, you need to do like this, right? And you have to check the points, x equal to point dot x and y equal to, means we are checking the current object with the next point, we can say. Okay, so it will compare each time, and this is the hash code we are generating based on x and y. Okay, so that's all. Thank you for watching this video. I'll request you, if you understood this problem, right, and I'll put this code into the comment box. So please make sure that you like this video, subscribe this channel, and hit the like button, so you don't miss the more coding videos. I'm planning to put some concise video lectures, so viewer can understand and can prepare for the FANG interviews and the product based interview. Also comment below if you want me to write a you want any help in the interviews, and any questions or any preparation guide, let me know in the comment section. Anyways, thank you for watching this video, and if you want to enroll in our upcoming uh, courses, right, I'm taking the live classes. If you want, you can join. Anyways, thank you for watching this video. Please write a WhatsApp message, and I'll connect with you. Thank you.